Here's what every HVAC company will tell you. If you want a cool house, you need a compressor, refrigerant, and a monthly bill. Here's what the numbers actually show. 6 feet below your yard, the ground holds close to 54 to 56 degrees. It stays there through the worst of summer in much of Pennsylvania and Ohio. They say cooling starts with machinery. The soil says cooling starts with temperature that barely moves. They say you need thousands of watts. Natural resources. Canada says a buried air tube works quickly. It delivers 82 to 85% of its temperature change in the first 34 meters. They say conditioned air must be manufactured. The Earth says it can be borrowed. I believed the first version for years. Then I started following the measurements. The reason you were never told the real number is simple. This system was written out of building codes in the 1970s. Someone had a very good reason to keep you in the dark. I am going to show you why a quiet buried system can cut summer cooling demand so hard. A 28-watt fan starts looking embarrassing next to a whole compressor. And yes, this works even if your house was built 50 years ago. Stay with me. Because what I found in Holmes County uses the same physics the Persians used to keep desert buildings livable 3,000 years ago. You have been trained to think comfort is manufactured. It is not. Comfort is managed. The air already wants to move. The ground already wants to equalize. The structure already wants to buffer swings if you stop fighting it. That is why this number matters so much. 54 to 56 degrees is not air conditioner cold. It is load-killing cold. Drop incoming air by 18 or 22 degrees before your main unit wakes up. The expensive machine does less of the job you pay it to do. That is where the bill falls, quietly, month after month. You feel the difference before the meter even notices. What makes this work is not mystery. It is thermal lag. The top inch of soil obeys the weather. The soil down around 6 feet does not. It behaves like a cast iron skillet left in a cool pantry. The room changes fast. The iron changes slow. When outside air moves through a buried tube, the surrounding dirt pulls heat from summer air. In winter, it pushes heat back in. Natural Resources Canada lays out the geometry plainly. Put the top of the tube at least 1.5 meters below grade. Keep the interior diameter around 0.15 to 0.25 meters. Hold air speed near 2 meters per second. Give the run 30 to 40 meters, because that is where most of the temperature transfer happens. That is engineering, not folklore. If you want the modern benchmark, I went to Oak Ridge National Laboratory. In its 2012 Foundation Heat Exchanger report, ground-coupled systems moved 3.6 units of heating for every 1 unit of electricity. In cooling, they moved 4.1 to 4.2. Electric resistance gives you 1 for 1. In this field, that ratio is called coefficient of performance. Your buried air loop is the stripped-down cousin of the same principle. It uses the earth as the sink, not the sky. Think of your car radiator in reverse. Your car dumps engine heat into moving air. This system dumps air heat into stable soil. The only paid input can be a small fan. Sometimes gravity does even that. There is another part people miss. Temperature is only half the trick. Humidity decides whether a room feels sharp, sticky, calm, or exhausting. Air in a properly sloped buried tube cools before it reaches your living space. Cooler air carries moisture differently than hot afternoon air. If condensate is drained correctly, you are not only trimming degrees, you are trimming latent load. That matters because your compressor does 2 jobs at once. It cools the air, and it wrings water from it. If the buried run handles part of the first job, your expensive system spends less time doing both. That gap represents a massive market in compressors, refrigerant, ducts, replacement parts, and service calls every year. And that is why you have never heard of this. I first felt it in Berlin, Ohio. It was late July. The road shimmered. The truck read 91 degrees at noon. Then I stepped into a banked workspace behind a farmhouse and felt the air fall against my face like creek water. No condenser hummed, no vents rattled. I heard one fan somewhere in the back. That was it. I stood there long enough for my arms to cool. Eli grinned at me and tapped the wall with 2 fingers. He said, "The ground does the work if you let it." Then he walked me behind the building. He showed me a buried line running from a shaded intake through the bank and into the room. No chrome, no touchscreen, no salesman, just slope, depth, and patience. He told me his people had used some version of that logic for 4 generations. It went back even farther if you counted spring houses and root cellars. He traced it through Lancaster families. Then he traced it farther back to people from the Palatinate and Canton Burn who settled in Pennsylvania and later Ohio. When I stayed longer in Holmes County, Eli walked me to a second building used for tools, seed, and canned food. The day had climbed to 94 degrees. Inside, my watch thermometer settled at 69. He laughed when I looked around for a mini-split. There was none. He pointed at the uphill side. Then he pointed at a shaded hedgerow. He told me the same sentence twice so I would not miss it. You win before the house starts fighting. That was the whole design philosophy in 9 words. I heard versions of the same thing again from Lydia in Lancaster County. She did not talk about efficiency ratings. She talked about behavior. She said the families she knew always separated the hot side from the cool side. They always shaded the intake, trusted depth over gadgets, and gave summer heat a high place to leave. 4 generations of use will teach you what no catalog teaches. The Amish did not read this in a textbook. They figured it out the way all real knowledge gets discovered, by paying attention to what the earth was already doing. That knowledge never disappeared. It was filed away. It was waiting. When I checked the paper trail, the same logic sat right there in USDA Design Number 1341 from 1929 and in Pennsylvania farm records that treated cooling by earth and water as normal farm sense. If you zoom out, the surprise gets bigger. In Yazd, Persian builders paired wind catchers with subterranean channels, and water so incoming air dropped into living rooms already cooled by earth. The Daulatabad wind catcher still rises 33 meters above the garden. In hot weather, that height and that mass matter. Then you go to Rome. You find hippocaust floors lifted on small pillars, with hot air guided under stone and tile before rising through wall flues. Different climate. Same lesson. Control the path. Use thermal mass. Move heat where you want it. Then go east again and you find Korean ondol floors. There, flues warmed stone from below and turned the building itself into the heater. Every civilization that mastered extreme condition arrived at the same answer independently. The Amish never forgot. They carried it from Canton Burn and the Palatinate to Pennsylvania and Ohio 300 years ago. They kept building it because it worked. They never needed anyone's permission to do what made sense, and that alone changes how you plan every room. The burial began with a business decision. In 1930, General Motors and DuPont formed Kinetic Chemicals to manufacture Freon. Mechanical cooling had already proven it could be sold by the room. Willis Carrier had the machine. Kinetic had the refrigerant. A house that stayed tolerable through dirt, shade, masonry, and airflow threatened far more than one appliance sale. It threatened the repeating money in compressors, motors, refrigerant charges, and service contracts. The suppression did not look dramatic. It looked official. In 1973, ASHRAE published Standard 62-73, Standards for Natural and Mechanical Ventilation. By itself, that title sounds harmless. It was not. Fresh air became a table, a rate, and a compliance target. NIST's history shows that in 1997, the language began converting into mandatory code form. By 2003 and 2004, The standard split into 62.2 for low-rise housing and 62.1 for larger buildings. The climate-responsive builder lost ground. The compliance industry gained it. The allies were easy to name. Carrier sold the machines. General Motors and DuPont sold the refrigerant through kinetic chemicals. Post-war magazines sold the aspiration. The Smithsonian's advertising archive shows Life magazine pushing packaged air in 1944 as family safety, baby comfort, and modern health. Government completed the circle by normalizing mechanical systems in public buildings and then in the standards you were trained to trust. Nobody told you. Not your builder, not your contractor, not the man who sold you tonnage. An entire field of knowledge disappeared from architecture schools and builder training. Not because it failed, because sealed houses, compressors, and service contracts paid better. And the pattern kept going. On March 3, 2021, the International Code Council Board voted to remove the final governmental member consensus vote from future IECC cycles. It moved the process into an ANSI committee structure. NEEP recorded that more than 75% of commenters opposed the change. NAHB later praised the new process, and Open Secrets lists $2.98 million in NAHB lobbying for 2023. Control the code table and you shape what gets built. The US HVAC equipment industry alone sits around $20.7 billion a year. Every passive retrofit installed is a compressor, refrigerant charge, and service visit that never gets sold. Now, if you already own a house and you're thinking this only applies to people with land, stay with me. Because this next part is specifically for you. You don't need to tear up your foundation. You need a yard, a drill, a weekend. If I were doing the simplest version on an existing house, I would start with one shaded intake. Then I would build one buried run. I would mark a trench 32 to 40 feet long. I would keep the top of the pipe 5.5 to 6.5 feet below grade. I would use a smooth 6-inch SDR 35 or Schedule 40 PVC line. I would not snake it all over the yard. I would keep it straight. I would give it a continuous 2-degree fall toward a condensate drain. Then I would bed it in 3 to 4 inches of washed gravel wrapped with geotextile fabric. At the intake, I would bring the pipe up with a long radius sweep. I would hold the screened opening 18 to 24 inches above grade under deep shade. Then I would add stainless mesh, a removable filter box, and a simple hood. At the house end, I would enter a crawlspace rim joist or a sealed window insert panel. Then I would mount a 6-inch inline EC fan that pulls 28 to 42 watts. That fan costs about $79 to $149. 40 feet of pipe usually lands between $160 and $220. Sweeps, couplers, mesh, sealant, and drain parts add another $54 to $96. You can build the first loop for $293 to $465 if you dig it yourself. Smooth wall pipe is not optional. Corrugated drain tile causes standing water, biofilm, and impossible cleaning. If I wanted more output from the same yard, I would not add more machinery first. I would add a second parallel run spaced at least 1 tube diameter away. 3 diameters is better when the trench allows it. I would keep each run under about 80 meters. Natural Resources Canada notes that longer runs give diminishing return after the major exchange happens. I would also keep the intake away from driveways, septic lines, and dryer vents. Clean air first, cold air second. That order matters. If your lot is tight, you can still cheat distance with a dogleg trench. You do not cheat slope. A fall of roughly 1 inch every 30 inches keeps condensate moving toward the drain. Put the low point where you can actually service it. Add a trap a gravel sump, or a daylight drain, depending on grade, then test airflow before you bury the last section. I use a strip of tissue at the outlet because it tells you direction instantly. Simple beats clever. You can also blend this with what you already own. Keep your existing central air. Keep your furnace. Let the buried loop become a preconditioner. Feed its outlet near the return side of your current system, or feed it into the room that overheats first. In winter, close the summer bypass. Let 20-degree air enter the house after it has already climbed toward the ground temperature band. That does not replace a heater in January. It reduces how hard the heater has to start from the outside extreme. Again, load first. Equipment second. I would seal every joint with the correct PVC primer and cement. I would add EPDM flashing where the line enters the house. I would put a clean-out T near both ends. If you want the outlet to feel deliberate, build a 24 by 24-inch plywood panel for a window opening. Mount the supply grill there. If you want winter shutoff, add a backdraft damper and one manual blast gate. That is another $22 to $38. One Saturday morning handles the layout. One long weekend handles the trench, pipe, and seals. On a 95-degree day, with shaded intake air and mid-50s soil, you can see outlet air. It lands in the high 60s to low 70s. That happens before it ever touches your existing system. That does not freeze your house. It crushes the load. Your main unit starts later, runs shorter, and cycles less. In shoulder seasons, you may not need it at all. Maintenance is simple. Check the screen every month in summer, replace the filter once a season, and inspect the cleanouts once a year. Your conventional central air costs $6,800 to $14,400 to install. It costs $118 to $247 per month to run in hot weather. It lasts 12 to 18 years before it ends up in a landfill. This costs $293 to $465 total. It lasts 25 to 40 years. Your choice. Everything I've covered across this channel, root cellar airflow, lime wash walls, gravity water, now lives in one place. It is step by step, season by season, room by room, in the order families actually use it. The full guide is linked in the description, but stay here. Because what Eli built behind that workshop is the part nobody is talking about yet. And that is why this still angers me. Not because the physics is hard, because it is simple enough for you to understand in one sitting. Once you see it, you cannot unsee it. You start noticing every place where a smaller bill was possible. You notice where the land under your feet was doing free work. You notice where somebody made sure your options began with something expensive. That is not ignorance. That is design. Not because it failed, because dependence pays. He did not stop at one line. He fed the cool air where the afternoon sun hit hardest. Then he used the house's own stack effect to pull warmth up and out. That is the part most retrofits miss. You do not just make cool air. You give hot air somewhere to leave. The Persians understood that. The Romans understood that. The Amish never forgot it. If you're the kind of person who believes real knowledge has been quietly pushed aside, you already know what to do. It protects somebody else's profit. Hit subscribe, not for me, for what comes next, because this is not a channel. This is a quiet movement of people who have decided they're done being sold what they already own. I want to hear from you. Drop your summer electric bill, your state, and whether your grandparents used a spring house, root cellar, or attic fan below. I read every single one. And your answers decide what we cover next. Next week, I'm going to show you what a 1929 USDA plan proves about cooling food, milk, and medicine without a compressor. The technique uses nothing but masonry block, moving water, and shade. And the federal farm design from 1929 proves officials knew about it 97 years before your contractor mentioned it. You're not going to want to miss that one.